Now, today we have lecture 2 of inverse trigonometric function, and our topic is properties of inverse trigonometric function. So, today we will learn the first property, property 1, and it is says that if you have circular function outside psi and inside is the inverse function sine inverse x, so what will be the answer? Answer is always x. Because when you give any input, it will first attack on sine inverse x. So therefore, your input must be less than equal to 1. So whatever you are giving as an input, you will get the same output. So see the proof of this result. Proof is, we assume that the sine inverse x is nothing but one angle. So we consider it is theta. So let sine inverse x is theta. So x will be sine of theta. But we know that sine theta value, we assume sine inverse x. So sine of sine inverse x, we have only x. I hope all of you understand these things. So now we are just drawing the corresponding graph of y is equal to sine of sine inverse x. Graph will be a straight line passing through the origin, not a straight line, it will be the some part of the straight line from -1 to +1. So if it is 1, here is -1. On the y-axis it is 1, and on the below the uh, y-axis it is -1. So this curve, this graph is the graph of y is equal to sine of sine inverse x. Okay, now it is x-axis. This one is the y-axis. Now similarly, we have the formula for cos of cos inverse x. You know that cos inverse x is defined for all x which is less than equal to 1. So it is also x. When you give any x, it attacks the cos inverse x function. And cos inverse x only take the input when x lying between -1 to +1. So what you notice that the graph of cos inverse x is a straight line when the domain is -1 to +1, and range will be the same, -1 to +1. So both the curve are identical. So this is the curve of y is equal to cos of cos inverse x also. Okay, now. So you can say that these two curves are identical. These two formulas are identical. But you can't say these are identical with y is equal to x straight line, because a straight line having the domain -infinity to +infinity and range is -infinity to +infinity, but it is has the range and domain same, -1 to +1. Now next is we have tan. So tan of tan inverse x, you know that tan inverse x is defined for every x. So it will be x for all x belonging to the real number. Same thing will happen for cot also. Cot of cot inverse x will be equal to x, and these x belonging to real number. So what we observe that the if you draw the corresponding graph, the graph will be a straight line here passing through the origin and making 45-degree angle with the positive direction of x-axis. This is the graph of y is equal to x, and this is the graph of tan of tan inverse x, and you can say that it is the graph of cot inverse of x, cot of cot inverse of x. part of cot inverse of x. Part of cot inverse of x. Okay. Now, so you can say that these three curve, these three functions are identical. These three are, you can say that identical because they give the same curve. The domain and range are same. So all these three are identical. All these three are identical. It is origin, x-axis and y-axis. Now, next is for the sec and cosec inverse. So if you take sec of sec inverse x, you know that sec inverse x is defined when x is outside of the -1 to +1. That means mod of x greater than equal to 1. So it will be x when you have mod of x greater than equal to 1. Similarly, you have cosec of cosec inverse x, and these also defined as x for all the x greater than equal to 1. So here we have the not whole straight line, but some portion of straight line we have here. Like first of all, you draw here you take 1 unit, here you take -1 unit, here also 1 unit, and here also -1. So by the dotted line, you first complete this square like this one. Now from this vertex, you can draw the ray, and from here you can draw the ray. Because what it is defined for more than equal to 1 and less than equal to -1. This is 1 and this is -1. After drawing the curve, you can rub this square. No issue. There is no need of this square for the drawing purpose. We draw it, okay, now, so that you can understand. So this is the graph of sec of sec inverse x and cosec of cosec inverse x. So these two functions are identical. These two functions are identical. Okay, so I hope all of you understand this part. Next, we have property 2. Property 2. This property is a little bit tricky, and questions generally come from this property 2. When we have the reverse case means previously we see that the circular function is outside and inverse function is inside. Now, if opposite happened, for example, your inverse function is outside and uh, circular function, trigonometric function is inside, then what we have? You have to find these things. Okay. So now, first of all, what is the value of these things? And we have to uh, find the corresponding graph also. So now, we assume that y is equal to sine inverse of sine x. From here, if I take sine inverse on the left hand side, so it will be sine y, which is equal to sine of x. So now from here, we can apply the uh, general equation, trigonometric general equation. So sine x equal to sine alpha. Then we find x equal to n pi plus -1 whole to the power n into alpha. So y is equal to what? N pi plus -1 whole power n, and this x. So what is the value of y? We assume it is sine inverse of sine x. Okay, sine inverse of sine x, and which is equal to n pi plus of -1 whole power n and then x square. Now all we know that the range of this sine inverse, whatever you give, the range is minus pi to plus pi, minus pi by 2 to plus pi by 2. Okay. So here we will select x and n such that our right hand side always lying between this minus pi by 2 to plus pi by 2. Okay. So for this purpose, what I'll do, suppose if I take this x as uh, actually minus pi by 2 to plus pi by 2. If I take x is equal to minus pi by 2 to plus pi by 2, then what will happen? You have to take n is equal to 0 because this range and this range coincide. So your answer will be x. So when you get x, whenever minus pi by 2 lesser than equal to x and less than equal to pi by 2, if these things happen, then you can say that the value is x. And when it is happened, when you choose n is equal to 0. When you choose n is equal to 0, then sine inverse of sine x must be equal to x. Next interval I will take, which is like after pi by 2 to pi length I will take. So minus pi by 2 less than equal to x less than equal to 3 pi by 2. So if x is more than pi by 2, so what we do, uh, since here the coefficient of x is plus 1, in the next step it will be minus 1. Alternately it will change. So our x will be something minus x. Okay. Now, so I have to select here minus x. So if I take here minus x, then what I choose the value of x. So now if your x is lying between pi by 2 to 3 pi by 2, so I can say that minus x lying between minus pi by 2 to minus 3 pi by 2. Now if I select here pi, that means n is equal to 1. If I add pi all the sides, then what will happen? This range will be pi by 2 and this range will be minus pi by 2. So if I choose here n is equal to 1, then I'll get pi minus pi by 2. Pi minus pi by 2. Sorry, the range will be minus pi by 2 to plus pi by 2 and here we get pi minus x. So next step, I will choose here. Suppose 3 pi by 2 less than equal to x and less than equal to 5 pi by 2. Again, the length of the interval is pi I am taking. Okay. So what we get, since x lying between 3 pi by 2 to 5 pi by 2 and this time x will be the positive because here x is having the coefficient negative. So now since x is positive, what I'll do, x is positive. Now we have to select some values of n so that the entire interval will be in the minus pi by 2 to plus pi by 2. So from x, if I subtract 2 pi, from x, from both sides, if I subtract 2 pi, what will happen? So it will be 4 pi, pi by 2, and here minus pi by 2. Yes. So this will work when you choose n equal to minus 2. If you choose n equal to minus 2, so it will be minus 2 pi. Now, next is, if I take here minus 3 pi by 2 lesser than equal to x and less than equal to minus pi by 2. Okay now. So since here x is positive, so here x will be negative. So if I choose here negative x, then what will happen? So it lies between pi by 2 lesser than equal to x and lesser than equal to 3 pi by 2. So now, since the value is more than pi, so I have to select x in such a way so that the value will be lying between minus pi by 2 to plus pi by 2. So if I subtract minus pi, if I subtract pi, then the will get the required range. So minus x minus pi. I think this part is clear to everyone. After getting this, we plot in the graph. So corresponding graph will be what? We know that Sine inverse of sine x always lies between minus pi by 2 to plus pi by 2. So this is our x-axis. This is we consider here y-axis. Now this line for pi by 2 and below line is minus pi by 2 for y equal to minus pi by 2 line, and here we have y is equal to pi by 2 line. This is origin x-axis and this is our y-axis. So what we see that minus pi by 2 to plus pi by 2, it is x. So if I take here minus pi by 2 and here minus pi by 2, so in this range we have y is equal to x straight line. Okay, now what we have y is equal to x straight line. Okay, next interval is pi by 2 to 3 pi by 2. So if I choose here pi and this is 3 pi by 2, so this will be what? Pi minus x line. This is for pi and this point for 3 pi by 2. We can write in this way. So now we notice that from minus pi by 2 to 3 pi by 2, that is the length is 2 pi. So in this 2 pi length, we will get one complete triangle, and this is for x. This is y is equal to x. And this line we have for pi minus x. This point is pi, and the equation of the line is pi minus x. So you can write here pi minus x. Now from 3 pi by 2, from 3 pi by 2 to 5 pi by 2, we have x minus 2 pi. This point is 2 pi, and this is 5 pi by 2. And this equation is x minus 2 pi. X minus 2 pi. Now on the left side, we have minus 3 pi by 2 to minus pi by 2. So here we have this length minus pi, and the equation will be minus x minus pi. So when I have drawn the curve, you have just notice something. When x is positive, that means when the slope is positive, line is pointing upward direction or increasing line. So in that time, you have to do variable minus the point through which the line is passing. So line is passing through the 0. So here you notice that this equation of the line will be variable minus the point through which the line passing. For this line, since the slope is negative, so you have to write number minus variable. Number through which point the line is passing pi minus variable. Again, this line is increasing, so you have to find variable minus the point through which the line is passing. So in this way, you can find out. Okay now. And one more thing you notice that when the coefficient of pi is even number, when the coefficient of pi is even number, so generally line passing through it will be the increasing line. So you can say that x minus even multiple of pi, even number, even integer into pi. So you have in that time slope, the line will be the increasing line. Line will be the increasing line. Okay. So x minus even multiple of pi will be the increasing line, and odd multiple of pi minus x. So if you take multiple of odd multiple of pi, the line will be the decreasing line. So it should be the odd multiple of pi minus x. And if you take even multiple of pi, so it will be the variable minus even multiple of pi only. Okay. So if you take odd multiple of pi, it will be odd multiple of pi minus x. So this line will be the decreasing line. I hope this part is clear to all of you. Okay. Now, from the graph, we can say something about this graph. So number one, the graph, from the graph, we can say that it is bounded function. It is bounded because it has a upper bound. Every value is lying between minus pi by 2 to plus pi. Next is, you notice that with respect to the zero, the curve is symmetric. Okay, now, so this curve is this is the odd function. This one is the odd function. And one more thing, the period of the function you can also calculate. It is the 2 pi. From here to here, one triangle is complete within the range of minus pi by 2 to 3 pi by 2. And this triangle will be repeatedly will come every interval of 2 pi when the length of the interval is 2 pi. So we can say that it is the periodic function and its period will be what? 2 pi. Its period will be 2 pi. Okay. Now? So now we are going to solve few questions on the based on this concept. We are going to find out the value of sine inverse of sine 3, sine inverse of sine 5, sine inverse of sine 21, sine inverse of sine 23, sine inverse of sine 17. These five questions we have to solve. So now we know that the graph of sine inverse of sine x. So from the graph, we first try to find out the values. Y is equal to, we know, sine inverse of sine inverse of sin x. We first draw the graph of this one. Okay, now this is our axis, x axis. This is suppose y axis, pi by 2 line, minus pi by 2 line. Here we know that this line is y is equal to x. We have this type of triangle here. So it intersects the x axis 0, pi, 2 pi, like that, 3 pi. And here it is pi by 2. And here you can find pi plus 2 pi, 3 pi by 2, and here 2 pi plus 3 pi, 5 pi by 2. So what we know that when the curve is increasing, variable minus point, so it is x minus 0. When the curve is decreasing, it is the number pi minus variable. Curve is increasing, so x minus number through which the curve passes, like this one. So we know that pi value is 3.14. And here we have to find 3. So 3 is just lesser than this pi value. It is our 3 position. So according to this point, uh, it is on the curve at this point. Okay. So for 3, we have this point on the curve. And this is the equation of the curve is pi minus x. So, but we say that sine inverse of sine 3 is nothing but pi minus variable. Variable is 3. Okay. Now we can calculate sine inverse of sine 5. So here pi 2 pi we know that 6 point something to 8, and we have to find pi sine inverse of sine 5. So we can do one thing, we can calculate this value 3 pi by 2 also work. Okay, now so you know that pi by 2 is 1.57, so 1.57 into 3 and this value is 4.71. 4.71. So this value is 4.71, but we want 5. So 5 will be here. Since 5 is here, so according to that, the 5, this point will be here. So x minus 2 pi will be the answer. So x means the variable which is 5 and 2 pi. So this will be the answer. Now sine inverse of sine 21, it is difficult to directly, we cannot extend the curve up to that point. So what we do, we try to find out in the interval like it is, you know that it is what, 21. So if I take 6 pi, next I am taking 7 pi. So 7 pi obviously more than that, 21. 6 plus 7, 13. So what is the value of 13 pi by 2? 13 into 1.57, 20.41. 20.4. It is 13 pi by 2, which is equal to 20.41. Okay, now, so what we know that if it is 6 pi, even multiple of pi, then we have x minus this even multiple of pi. Okay, now, so here we have these things. So it is x minus even multiple of pi. When the curve is decreasing like this one, here we have number minus variable x. Now our value is 21, which is just more than 20, like here. So according to that, we have the point on this line. So sine 21, it will be 7 pi minus 21. Okay. Next is 23. 23, what can do? 8 pi, if I take, it will be 24 point something. And if I choose here 15 times of pi by 2, what will be the result? Let me check. 15 into 1.57, 23.55. So this point is 23.55. Okay, now, so from here we can find another line passing through this one. So this 15 pi by 2 is 23 point something. So our 23 will be here. So for 23, we have this point on the graph. That means again 7 pi minus variable. So we can write sine inverse of sine 23 is equal to 7 times of pi minus variable 23. Okay, very good. Now it is 17. So 6 pi, we know that 18 point something. This will be here. We have 5 pi. Okay. This point is 5 pi. So 15 point something. And here we have 5 plus 6, 11 pi by 2. So I have to find out 11 pi by 2 value is what? 11 into 1, 5, 7, 17.27. So this value is more than 17. So our 17 value will be here, like this one, because it is 17.27. So 17 will be in this form. Since it is the decreasing curve, so what we know for the decreasing curve, we have uh, number minus variable. We have number minus variable. So now sine inverse of sine 17 will be 5 pi minus variable is 17. So I hope this graph is clear to all of you. I think this part is clear to everyone. How can we find out the value of sine inverse of sine some number through the graph? Okay now. So next we will read cos inverse of cos x function. and then we will do some problem on this. So our next function is uh, y is equal to, suppose we have cos inverse. Outside is the inverse function and inside is trigonometric function. So this value we want to find out, and you know that this cos x is defined for every x. So here also domain is set of all real number. In the previous property also, in the previous property, here, here also, where it is this one. I think I have written no. So this function is defined for all x belonging to real number. So first of all, we have to proceed just as the previous method. So we take cos on the left hand side, so it will be cos of y, which is equal to cos of x. So now, general solution we are going to find out in trigonometry, general solution. So this we can write as y is equal to 2n pi plus minus x. X is the variable, 2n pi plus minus x. So y value, we know it is cos inverse of cos x, and this side is 2n pi plus and minus x. All we know that this cos inverse has the range of 0 to pi. So whatever we find on the right hand side, that value must lies in the range of left hand side, because left hand side is fixed 0 to pi. So what we will get, suppose if I choose x 0 to pi. If I choose x 0 to pi, what will happen? So that means you have to take n is equal to 0. So on the right hand side, we have the whole range 0 to pi, and in the left hand side, it matches. So the value will be x. So when you take the original range of the left hand side, then the value is always x. Now we'll move to the next value, pi lesser than equal to x lesser than equal to 2 pi. Then what will happen? So first x has the coefficient positive, next x will be minus x. We know that it alternately positive and negative. So now if x is minus x, so from in we have to choose something so that the range will be 0 to pi. So this function will become like this one, this inequality, minus 2 pi less than equal to minus x and less than equal to minus pi. We want 0 to pi, so we add here 2 pi on both sides. So it will be 0 less than equal to 2 pi minus x and less than equal to pi. So what we have to do, we have to choose n is equal to 1 on that. So it will be 2 pi minus x. 2 pi minus x. Okay now. I hope this part is clear to everyone. Next is, suppose if we take here 2 pi lesser than equal to x and lesser than equal to 3 pi. So in this time, x will be what? X you have to take positive. So it will be positive. So now, what we should subtract so that we will get 0 to pi range. We subtract from all sides 2 pi only. 2 pi if we subtract, we will get same value. So now, here we have minus pi lesser than equal to x, less than equal to 0. Minus pi to 0 interval. To just multiplying x by minus x, we will get 0 to pi interval. I hope all of you understand this part. Now, according to that, we are going to plot the graph. So what we know that it lies above the x-axis. This is our x-axis, and this is suppose y-axis, and this is for horizontal line pi 0. So 0 to pi, it has a straight line like this one, 0 to pi. Then pi to 2 pi, again you have this type of line. So it is 0, then it is pi, and then it is 2 pi. So 0 pi and 2 pi. So 0 to pi, the line will be x only. When it is decreasing, it will be number minus variable, 2 pi minus x, like this one. After that, it will be again the triangle will repeat here, repeatedly present triangle. So 2 pi, then we have here 3 pi, then you have here 4 pi, then 5 pi, and then 6 pi. Okay. So here also increasing, here also increasing. So you have x minus 2 pi. This side you have decreasing to 4 pi minus x. And here you have x minus 4. Like this. On the left hand side, same type of triangle you obtained here. 0 minus pi minus 2 pi. So it is a decreasing curve. So you have 0 minus x or only x. It is increasing curve. So it will be x minus of minus 2 pi. That is x plus 2 pi. So this is the curve of this cos inverse of cos x. From the curve, we have some few point. We can say that you notice that along the y-axis, whatever we have on the right hand side, same part reflection on the left hand side. So you can say that this function is the even function. And moreover, it is the bounded function because lying between 0 to pi. And you also see that this function is periodic and it repeats itself. So every this periodic function has the period 2 pi. Now we will solve on the basis of this concept. We have to solve few questions. Now try to solve few questions. We are going to solve few questions. But first part is cos inverse of cos 3. So cos inverse of cos 3. Now in this curve, you notice that 3 pi means what? 3.14, which is less than 3. So 3 will be here, somewhere here. And according to this, it lies on this straight line, yellow straight line. And the yellow straight line equation is y is equal to x. So therefore, from here you can write the answer will be cos inverse of cos is nothing but the input, that is 3. If you take 4, 4 is just slightly greater than 3.14. So 4 will be here, suppose. So now if 4 is here, so what we see that the 4 lies on this straight line, and this straight line is the 2 pi minus of the variable. So 2 pi minus 4, x is 4 here. For the question number 3, we have to find 7. 7 is what? 2 pi is 6.28, 3 pi is 9 point something. So here it is present 7. So for 7, we have this number, that is 7 minus 2 pi. Now we have 23 and 50. 23 is, you can do one thing. 23, na? So 6 pi, 7 pi, 8 pi. So we can do one thing. We take 7 pi, then we take 8 pi, then we will take 9 is enough. 6 pi, 7 pi, 8 pi, yes. Okay. Now here we have 6 pi also. 6 pi. Now what we can do that 6 pi is what? 6 into 3.14. I'm using the calculator only for the to save our time. So it is 18.84. But you have to do the calculation your own. 7 into 3.14. It will be 21 point something. 21.98. Okay. Now 8 into something is there. 8 into 3.14, which is 25.12. What we notice that now if it is 6 pi, so curve at the odd multiple of pi, there will be the peak. Every odd multiple of pi, there is a peak. Okay, so here is one peak is here. Now our functions will be look like this one and this one. And we have what? 23. It is 21, 23 will be here, somewhere here. And for 23, we have this point is here. Now this is the decreasing curve. So number minus variable, number is 8 pi minus variable x. Here our x is 23. So here we can write 8 pi minus 23. And similarly, we are going to calculate 50. 3, 16 into pi. 16 into pi, we can calculate 16 into 3.14. So it is 50.24. Okay. So now 16, uh, you can to feel like this. Suppose I'm taking here 16 and here I have 17, 16 pi, 17 pi, and then we have 16, 17, no, no, it's 15, it is 15. I move to the left hand side, 15 pi, and then it will be the 14 pi. 14 pi. 16 pi is 50.24. It is 50.24. So what we know that curve will be like this one and curve will be like this one because at this point 15 pi there will be the peak. So here equation of the line is 16 pi minus variable. Here the equation of the line is since it is increasing to x minus 14 pi is x minus 14 pi. This side is x minus 14. Now our value is 50. So 50 is just slightly less than, so this will be the 50. And for 50, we have this line, we have this line, and equation is 16 pi minus x is 50 here. So 16 pi minus 50 is the correct answer. So in JEE mains, this hope all of you enjoy this concept. In JEE mains, it is one of the important topic. We will get some questions common from here. So our next target is tan inverse of tan x. Okay. So tan inverse of tan x is so simple compared to the sine inverse of sine x and cos inverse of cos x. So you simply write tan inverse y is equal to tan inverse of tan x. And here you know that x will be any real number except the odd multiple of 90 degree. So 2n plus 1 into pi by 2 we can't take. And also you know that this range of this function is minus open bracket minus pi by 2 to open interval pi by 2. Okay now. So now what we do, we will solve in this way. Tan y is equal to tan x. So from here we can write y is equal to n pi plus of x. Tan x equal to tan alpha, x is equal to n pi plus alpha. So every time here x is the has the coefficient positive one. So therefore you can say that cos tan inverse of tan x, this function is always the increasing function. Okay. So here, if you want to, mm, you can do that, write the values of y directly, which is tan inverse of tan x. So now this left hand side is lying between this range. So you have to select x in such a way so that it will be in this interval. So our first target is we are going to take x between this range. So if you choose in this range, what will happen? Your n becomes 0 and whatever you give input, that will be the output. After pi by 2, you will take x as pi by 2 to 3 pi by 2 in this range. What will happen? Now you have to make in the interval minus pi by 2 to plus pi by 2. They're just doing the subtraction with pi. If you do the subtraction with pi, you will get the correct answer. So n is equal to, here it is 0, here n is equal to minus 1. Next, if you are taking 3 pi by 2 lesser than x and lesser than 5 pi by 2, then it will be x minus, if you subtract the 2 pi, you will get the answer. So n is equal to minus 2. Yes, minus 2. Take one value just before minus pi by 2 to pi by 2. It will be minus 3 pi by 2 lesser than x lesser than minus pi by 2. Now it will be what x. Since the value is more negative, you have to add some positive quantity. So that is pi. You have to choose n is equal to 1. So now if you put pi, you will get the answer. And the graph is so easy compared to tan and cot inverse. Just trying to draw the curve here. Yes, here you can draw the curve. So this is nothing but minus pi by 2 to plus pi by 2. So this will be like y is equal to x. Okay. And change the color. You can use white color. But it cannot touch the line pi by 2 and minus pi by 2. This is our origin. So there will be the empty circle. Again, it is minus pi by 2, 2 pi by 2 we draw. Now next is what? Again, you have this kind of graph. Parallel lines you have. I hope all of you understand what is going on. There will be the empty circle here. So minus pi by 2, then pi by 2 you have here cut at the point pi. So it will be 3 pi by 2, 3 pi by 2. Then it is what? 2 pi. And then you have got 5 pi by 2. So 5 pi by 2 you have got like this one. So now for the first part you have the answer x, and here you have x minus pi, then you have x minus 2 pi delta. Okay. In this side also you can draw like this one is your curve, and it cuts at minus pi, so it will be x plus pi. Okay. From the curve, what you observe? From the curve, what you observe that whatever on the if you move towards from the zero, whatever you are achieving the value, same value you will get when you move towards the left of zero. So therefore, you can say that number one point, the curve is the what you can say. So curve is even I can say it is the odd curve. Next is you cannot get any value, any range is infinity. So therefore, it is the bounded. And one more thing, the curve is repeats itself after the interval pi. So this is a periodic curve with period pi. With period is equal to pi. Okay. So now, the basically the problem will not come from here. Sine of sine inverse and cos of cos inverse are the important part. From there, curve will come, or questions will come. Now, going to solve cot inverse of cot x. So you notice that cot inverse of cot x uh, is same as our tan inverse of tan x. Why? Because here you notice that x can take any value except the multiple of pi. Okay, now. So now why if I take cot inverse of cot x, so I can say that cot y is equal to cot x. So therefore, from here we get tan y is equal to tan x. Now, why we can say that tan inverse of tan x. So whatever the graph of tan inverse of tan x we have, same curve we have for the cot inverse of cot x. But here some restriction is there. The cot inverse of cot x has the range 0 to 5. In this range, x cannot be in this range we have fixed 0 to pi, but domain in the domain we don't have any multiple of pi. Multiple of pi you have to exclude it from the tan inverse curve, and then here the tan we get the same curve tan inverse, but the range will be 0 to pi. Then above the x-axis, so we have it is our x-axis. It is suppose pi line, and it is our y-axis. So now 0 to pi we have to take. 0 to pi. So this is like this one you are getting 0 to pi. So cot inverse of cot x to be open bracket 0 to pi. On open, we know that it is within the open bracket 0 to pi. So therefore, where will be the right? We have this one. Here will be the empty circle on the both end. Okay, is it clear to everyone? So this one is the x minus 0, and this will be what? X minus 5, like this one, it will goes. You can x minus 5, x minus 2 pi, like this one. Next is, if I have y is equal to sec inverse of sec x. So here also, you can take range is anything, domain is anything you can take, but you know that at the odd multiple of 90 degree, it is not defined. So you have to subtract odd multiple of 90 degree, because at this point cos is 0, therefore sec is undefined. So from the cos curve, and one more thing, the sec is defined for wet to air. Its range will be 0 to pi, same as the cos. But at the pi by 2, it is not defined. Okay. In the domain, we have to uh, remove the pi by 2. Okay. So what we have cos curve, we have to form from 0 to pi. Cos curve, no? 0 to pi. Isn't it? Suppose this is our cos curve from 0 to pi, we have this full triangle, okay, no? 0 to 2 pi. So now we repeat this triangle because it is a periodic function. Same curve we have, but you know that what it is not defined at the 90 degree. So there will be a hole in the 90 degree. It is pi, and this will be the line of pi by 2. Where this line cuts the curve, there will be a some hole. So in the curve, there is a hole at these points everywhere. Okay, so there will be the hole in this curve. Next, we have y is equal to cosec inverse of cosec x. So here you know that except pi by 2, except pi by 2. Here also it is defined for every real number except multiple of n pi, and its range will be minus pi by 2 to pi by 2 except 0, except 0. So here we know that the uh, graph of sine inverse of sine x. So from sine inverse of sine x curve, we remove the 0 point. Okay. So here the triangle will be look like this way. One triangle complete. Then we will draw the same triangle here. If you want, you will draw one more triangle on this side. Okay. Now, whatever we are doing after that, we have to remove this 0 point. Where x is 0, we have to, y is 0, we have to remove. Okay. The points where the domain is multiple of n pi, right? You have to remove those part. Okay. I think all of you understand this thing also. Now we will going to learn the next properties. We are going to solve this question when x is an integer. Now, first of all, we draw the graph of sine inverse of sine x. This is the graph. It is minus pi by 2, then pi by 2, and then it is pi. This point is pi, this point is 0. So, and this is what? like this one. Now 0 pi, this will be 2 pi. Okay, our value is 4. 2 pi is 6, and here 2 plus 1, 3 pi by 2. So we have to find 3 pi by 2 value. You can say that it is 3 into 1.57, which is 4.71, more than 4. The 4 will be somewhere here. So if 4 is here, then the value will be in this point, okay, on this line. And the equation of the line is pi minus x. So we can write this is 2 into pi minus 4. Cos inverse of cos 4 we have to find out. So we know that cos inverse of cos 4 lying on the x-axis, and it will be look like this: 0, then it is pi, and then it is 2 pi. So value is what? 4. 4 is just more than pi. It will be here, and this value, this line's equation is 2 pi minus x. So it will be 2 pi minus 4. Okay. So from the graph, we first find out this value and then solve it. 3x square plus of interest. Now the remaining work is just you have solved the inequality in the lower classes. Same you have to do. 2 pi cancel out, minus 8 plus 4, it will be minus 4. And here you have 3x square plus of 8x and plus 4 lesser than 0. 3 into 4, 12. And so you can write as 3x square plus 6x plus 2x plus 4 lesser than 0. Okay, so 3x you can take, it will be x plus 2. Then if you take 2 common, it will be x plus 4, which is lesser than 0. So our factors will be x plus 2 and 3x plus 2, which is less than 0. So from here we have x is lesser than uh, 3 by 2 with negative sign and more than minus 2. So between minus 2 and minus 1.5, no integer is there. No integer is there. Okay. So I think answer is 5. No solution. No solution. Okay. Now solving more questions. Take another questions. Next question is cos inverse of this one. If these things is a pi by 7, b pi by 11, c pi by 13, d pi by 5, find the value of a plus b plus c plus d. Don't worry. So we can write cos inverse is cos, because its range is 0 to pi and 10 pi by 7 is more than pi, so we reduce it. Okay, now we can write 2 pi, 7 into 2, 14, to 4 pi by 7. So this quantity is, this value is lying totally between the 0 to pi. So we can take cos inverse, cos inverse, cos of 4 pi by 7. And this is equal to 4 pi by 7. Okay. So from here we will get a is equal to 4. Now next value is this one, sine inverse sine 35. We can take sine inverse. Now this we can write as 3 pi times of 11, 33 and 2 pi. Okay. This will be sine inverse, and sine of 3 pi by 2, 3 pi plus 2 pi by 11 is minus sine 2 pi by 11. Okay. Now sine is the odd function, so negative will be outside, so it will be 2 pi by 11. So therefore we get b value is minus 2. Coming to the third part we can solve. Uh, Negative sign is there and tan is the odd function, so negative one outside. We have tan inverse. This we can take tan of 2 pi minus, this is if I take 13, 13 into 2, 26, and then we have 2 pi. So it is in the fourth quadrant. So again, negative will come. -1 tan inverse minus of tan 2 pi by 13 for the fourth quadrant. So from here we have plus 2 pi by 13. So C we have 2. Now for the mm, last part, this value we can calculate here. Okay, now due to the place is very small there. So cot inverse cot, this cot we can write 26 pi. So this will be 5 pi plus 25 plus pi 26. Okay. So this will be cot inverse of cot 5 by 5. That means 5 by 5. So here D is 1. D is 1. So now when we add all these values A plus B plus C plus D, we will get 2 to cancel 4 plus 1 5. This is our answer. Okay. Now coming to the next one. Okay, now this is very well-known result. This is actually the value of tan pi by 8. Tan pi by 8 is root over of 2 minus 1. But here you notice that cot inverse present. So I want to change this value tan to cot. So tan theta can be written as cot of 90 degree minus theta. If I multiply with 4, it will be 4 minus 1, 3 cot of 3 pi by 8. Okay, now we take the problem like sine inverse, cos, then 2, and cot inverse of cot 3 pi by 8. So it will be 3 pi by 8. Now we have sine inverse cos of 3 pi by 4, which is nothing but cos of 135 degree, and its value will be minus 1 by root 2. And all we know that sine inverse is a odd function. It will be sine inverse 1 by root 2, in which angle sine produce 1 by root 2 pi by 4, and there is one negative sign. This result is proved. Now we have few more questions. Sine inverse of sine 10 pi by 7, but we know that sine inverse has the range minus pi by 2 to pi by 2. So we cannot directly take 10 pi by 7, so we have to simplify. So these sums we can solve in this way. Sine inverse, and this you can write as sine of pi plus 7 pi plus 3 pi 10 pi. Okay, like this one. So this can be written as 7 pi, and then sine 7 pi, it will be on the third quadrant, to minus of 3 pi by 7, minus 3 pi by 7. And sine inverse of sine minus 3 pi by 7, sine it is a odd function, will take negative sign outside. So sine inverse of sine 3 pi by 7, and this value can be written as minus 3 pi by 7. Now solve. So now we are going to solve this question. Question number 2. This is solution of 1. Solution of 2. Cos inverse sine minus pi by 9. So this problem we can write as cos inverse. This is minus sine pi by 9. But outside is what? Cos inverse. So this sign I want to change in cos. So therefore I can write so that negative sign will also be absorbed. So cos of 90 degree plus theta, it will be minus sin theta. So check this value. If I do here cos inverse cos, take the LCM, it will be 18, then 9 pi, now into 2 pi. So it is the 11 pi, but its range is 0 to pi. Okay, 11 pi by 18, we can take no issue. It will be 11 pi by 2. This problem we will solve in the next page. Okay. Third one. Now, here what we have, sine inverse of cos. Our target is first we change this, reduce the angle. It will be cos. If I take 3 pi and into 10, 30 pi and then 3 pi. So this will be sine inverse cos 1 pi, 2 pi, 3 pi. And then it is a negative because in the third quadrant, so we can write cos of 3 pi by 10. Okay. But cos inverse is an odd function, no problem. We can take minus outside. So it will be sine inverse cos. I can write sine 90 degree minus theta 3 pi by 10. Now pi by 10, if I multiply with 5, this 5, this is also 5. So 5 minus 3, 2. Okay. So it will be sine 2 pi by 10, which is same as pi by minus pi by 5. Now we are going to learn property 3. Property 3. Property 3. Number 1, part 1. Cosec inversions. What we know that it is defined when mod of x greater equal to 1. When mod of x greater equal to 1. So this will be sine inverse of 1 over x. Okay. Next is when you have sine inverse of x, so it is defined for all x lesser than equal to 1. And when you change into cosec inverse x, and this function is not defined when you have x is equal to 0. So x cannot be 0 because sine inverse x is defined between minus 1 to plus 1, and in that value, one point is 0 also. And 1 by 0 is not defined for the cosec inverse x. So what we can say that these two functions, we can say that are not identical because their domain are separate, are not identical. Okay. Similarly, if you take 2 sec inverse x, it can be written as cos inverse 1 by x. Sec inverse x, that means mod of x is greater than 1. If you choose cos inverse x, then it will be sec inverse 1 by x, only defined when you have mod of x lesser than equal to 1 and x cannot be 0. So not identical. It is also not identical. But point, if you have cot inverse x, this can be written as tan inverse x, tan inverse 1 by x. It is only true if you take x is positive number, positive real number, and if you take something negative, it will be pi plus of tan inverse 1 by x when your x is negative number. I'm doing the proof of first one. Proof of first one, like cosec inverse x, we can write as sine inverse 1 by x when our x mod of x greater or equal to 1. How we can prove that? So first of all, let cosec inverse of x equal to theta. Okay. So since we are taking cosec inverse of x is equal to theta, so what is the range of cosec inverse? Lying between minus pi by 2 to pi by 2 except 0. Except 0. So from here we can get x which is equal to cosec theta, which is equal to cosec theta. Since theta cannot be 0, so we can take the reciprocal, it will be sine theta. And from here we'll get 1 by x. So we can say sine theta will be equal to 1 by x. Now if I take both side inverse, then what will happen? So it will be sine inverse of sine theta, and here you have sine inverse of 1 by x. Now sine inverse has the range minus pi by 2 to plus pi by 2. So therefore we can take and this sine theta, this theta lying between this range, so we can take no problem. So theta will be sine inverse of 1 by x because its range is minus pi by 2 to pi by 2. Okay, now, so sine inverse 1 by x we have. So from here, theta we consider cosec inverse of x, which is equal to sine inverse of x. So hence it is proved. Next part relating to the cot inverse, this formula we prove because where pi is also present. So now prove the third one, cot inverse. The third one, cot inverse x is equal to, first we prove tan inverse 1 by x when x is positive. So let cot inverse, since it is an angle, I assume as theta. And since x is a positive number, so our theta lying between 0 to pi. So theta belonging to 0 to pi, pi by 2 in first quadrant. So therefore x will be the cot theta. So we can take the reciprocal, it will be tan theta and it will be 1 by x. So from here we can write tan theta is equal to nothing but 1 by x. Both sides if I take inverse, it will be tan inverse of tan theta, and theta belongs to 0 to pi by 2. So therefore we can easily, this range of tan inverse, you know that 0 to pi by 2, this range is minus pi by 2 to pi by 2. And your theta value is the subset of this set. So you can easily apply the formula. So it will be tan inverse of 1 by x. And theta you assume as nothing but the cot. So it will be cot inverse of x. So this part is proved. Coming to the second part, if you take x is less than 0, therefore, and if you assume cot inverse of x equal to theta, so x is negative, so output will lie in the second quadrant. So it will be lying in the second one, like this one. So from here you will get x is equal to cot theta. So now you can write 1 by 1 by you can write tan theta. 1 by cot theta means tan theta. So you can write tan theta is equal to 1 by x. Now if I choose tan inverse on both sides, tan inverse of tan theta So it will be tan inverse of 1 by x. Now, tan inverse of tan theta will be theta. Obviously not, because your theta lying between pi by 2 to pi. So since theta or theta is pi to pi by 2 to pi, and this is between minus pi by 2 to pi by 2. So what we have to do, we have to subtract something. So from pi by 2, if I subtract pi, the range will be no problem. So if I subtract pi, so it will be minus pi by 2 to 0. No issue, so we can write this value is theta minus pi, which is equal to tan inverse of x. This we can write theta is equal to pi plus of tan inverse 1 by x. Now what is your theta value? Your theta value is cot inverse x. So cot inverse of x is equal to pi plus of tan inverse of 1 by x. Okay. So now these things we want to prove. I hope this part is clear to everyone. Next is property 4. Property 4. Number 1, sine inverse of minus x, written as minus sine inverse x. Next is tan inverse of minus x. You can write as minus tan inverse x. Then third one is cosec. Cosec inverse of minus x. It will be minus cosec inverse x. Okay. But about these three, where you have cos inverse of minus x, this value will be pi minus cos inverse of x. Next, cot inverse of minus x, it will be pi minus cot inverse x. Next is sec inverse. Sec inverse, sec inverse of minus x, it will be pi minus sec inverse x. This three is nothing but the odd function, and from this I want to prove one result. Suppose it is 1, it is 2, it is 3. This result is 4, 5 and 6. So from 1 to 3 I prove one result, and from 4, 5, 6 one result. So proof of one, result 1. Let sine inverse of minus x is equal to theta. So what we know, that theta must belongs to minus pi by 2 to pi by 2. So therefore we can write sine theta is equal to minus x. So now we can write x equal to sine of minus sine of theta. So this can be written as sine of minus theta is same as sine theta. Take inverse on both sides. So we can write sine inverse of x is equal to sine inverse of sine of minus theta. Now the question arises, this function is lying between minus pi by 2 to pi by 2. And this theta while lying same, minus pi by 2, pi by 2. So therefore we can write as minus theta. So now what we have, sine inverse x So here we have, you can write here, this value is sine inverse x. So sine inverse x we have minus of theta, minus of theta. Theta we assume at sine inverse of minus x. So we can write, therefore sine inverse of minus x is equal to minus sine inverse x. I hope all of you understand this concept. Now I want to show you for the these 3, 4, 5, 6 how we get the pi. Okay, na? So see the proof. Cos inverse of minus x. For cos inverse of minus x, we want to prove pi minus cos inverse x. So what we do, solution, let cos inverse of minus x is equal to theta. So theta must lie between the closed interval 0 to pi. From here we get minus x, which is equal to cos theta. Now you can write simply x, which is equal to cos of minus cos of theta. So this can be written as cos of 180 degree minus theta, which is same as minus cos theta. Okay. If I take inverse on both sides, it will be cos inverse x. It will be cos inverse of cos of pi minus theta. Now the range of cos inverse is 0 to pi. The question arises, pi minus theta is lying from where to where? Theta belonging to 0 to pi. So if I take minus theta, so it will belong to minus pi by 2 to 0. If I add again pi, it will be pi minus theta belonging to 0 to pi. Same as the range of cos inverse x. So therefore we can write pi minus theta, which is same as cos inverse of x. Now just switch the sides. It will be theta, which is equal to pi minus cos inverse x. Now we have theta is nothing but cos inverse of minus x, which is same as pi minus cos inverse x. Okay, now I hope all of you understand this one. And next properties, just let me check. It is the property number one. Property three, three completed, four completed, property four completed. Now property five. Okay, we have property 5. This is the last property of this session or of this lecture, property 5. So here we have three properties. Number one, sine inverse x plus cos inverse x is equal to pi by 2. This property holds if mod of x less than equal to 1. Number two, tan inverse x plus cot inverse x is equal to pi over 2, and it is true for mod of x. Tan cot, it is for our real number. We can say x belonging to all real. Third one, sec inverse x plus of cosec inverse x, which is equal to again pi over 2. And here we know that x mod of x will be greater equal to 1. So here I am doing the proof of any one. The rest we will do in the you have to do as a homework. Proof of 1. So let sine inverse of x is equal to theta. So we can say that theta belongs to close bracket minus pi by 2 to pi by 2. From here we get x equal to sine theta. Okay. Now this sine theta we can change into the co-function cos of 90 degree minus theta. Okay. So now what we are doing, we are taking on both sides cos inverse. So this will be cos inverse of x, which is equal to cos inverse of cos pi by 2 minus theta. Now the question is, This range is 0 to pi. Can we say that directly this pi by 2 minus theta will be in this range? To calculate minus theta will be what again from minus pi by 2 to pi by 2. This is minus theta. If we add pi by 2, what will be this range? 0 to pi. So therefore, absolutely this value lying between 0 to pi, the cos inverse and cos will produce pi by 2 minus theta, which is equal to on the left hand side cos inverse x. Now shifting theta on the left hand side, we can write theta as sine inverse x plus cos inverse x and which is equal to pi by 2. Similarly, other two result you can prove at. So I hope all of you enjoy this class and in the lecture 3 we will do some more property and we will solve more questions and if you like my teachings, if it is beneficial for you and will be if you will be benefited by watching this, so please subscribe my channel and share this channel with your friends and tell them about this channel so that maximum student will be benefited by this program. Now we will meet again in the next class. Till then, bye. Have a nice day.